Hi there. On this video, I'm going to discuss Module 7, which is WAN Concepts. Alright, so for the module objectives, okay, so this is WAN Concepts. So at the end of the module, so we'll be able to explain how WAN access technologies can be used to satisfy business requirements. Alright, so we have a specific topic title here. You've got the purpose of the WAN. So we will be able to explain the purpose of the wide area network. You'll have the WAN operations, explain how WANs operate. All right. So you've got traditional WAN connectivity. So we are going to compare traditional WAN connectivity options that they used before. And you also have the modern WAN connectivity. Okay, so compare modern WAN connectivity options. Okay, so would it be available on our work area? And you also have the internet-based connectivity. And then we are going to compare internet-based connectivity options and its availability in our area. Okay, so let's get started. So basically we are going to cover the purpose of the wide area network. Okay, and before we proceed, okay, so let us compare wide area network and local area network. So a wide area network, or WAN, is a telecommunications network that spans over a relatively large geographical area and is required to connect beyond the boundary of the local area network. So this is something like connecting offices from one area, for example, in Asia, okay, so to one of its office in the US. All right. So in that scenario, we need to use a telecommunication lines to connect, okay, these two areas, and that's beyond the boundary of the local area network. All right, so comparing the local area network and the wide area networks, basically LANs provide networking services within this small geographic area. So it might be within the office, within the building, within the campus, so we call it LAN. All right, so whereas the wide area networks provides networking services over the large area. It might be spanning over um, or from one country to another. Okay, it spans over geographical areas. All right, so continent to another continent and so on. Local area networks are used to interconnect local computers, peripherals, and other devices, whereas wide area network are used to interconnect remote users, networks, and sites. All right. So a local area network is owned and managed by an organization or a home user, whereas wide area network are owned and managed by internet service providers or ISP or telephone, cable, and satellite providers. All right. So other than the network infrastructure costs, there is no fee to use a local area network. Whereas for the wide area network, WAN services are provided for a fee. Okay, so you need to subscribe. For LAN or local area network, LANs provide high bandwidth using a wired Ethernet or a Wi-Fi services. Whereas for the wide area network, WANs provide or WANs providers offer low to high bandwidth speeds over long distances. All right, so from the figure here, we can say that this enterprise campus, all right, is connected via a local area network. Okay, so and we have remote sites. Okay, so it might be from different locations in the country or other countries, and you also have the roaming users here who wants to access your local area network, and that is possible via the use of wide area networks. All right. Okay, so let's talk about the private and the public ones. So a private one is a connection that is dedicated to a single customer. So private ones provide the following: so guaranteed service level, consistent bandwidth, and security. A public WAN connection is typically provided by an ISP or telecommunication service provider using the internet. So in this case, the service levels and bandwidth may vary, and the shared connections do not guarantee the security. Okay? So for the WAN topologies, so physical topologies describe the physical network infrastructure used by data when it is traveling from the source to a destination. So the physical WAN topology used in WANs is complex, for the most part unknown to users. Consider a user in New York establishing a video conference call with a user in Tokyo, Japan. So other than the user's internet connection in New York, it would be feasible to identify that all the actual physical connections that are needed to support a video call. So instead, WAN topologies are described using a logical topology. Logical topologies describe the virtual connection between the source and destination. So for example, the video conference call between the user in New York and Japan would be a logical point-to-point connection. All right? So WANs are implemented using the following logical topology design. It could be a point-to-point topology, a hub-and-spoke topology, a dual home topology, fully meshed topology, or a partially meshed topology. Okay? All right, let's talk about the point-to-point topology. So a point-to-point topology, as shown here in the figure, employs a point-to-point circuit between two endpoints. All right, so it involves a layer 2 transport service through the service provider network. The point-to-point connection is transparent to the customer's network. Okay, so it can become expensive if many point-to-point connections are required. Next is hub and spoke topology. So a hub and spoke topology enables a single interface on the hub router to be shared by all the spoke circuits. Spoke routers can be interconnected through the hub router using a virtual circuits and routed interfaces. So the figure here, all right, shows a sample hub and spoke topology consisting of 3 spokes. You've got spoke A, B, and C, all right, connecting to a hub router across the cloud. Okay? So spoke routers can only communicate with each other through the use of the hub router. All right, so next is the dual home technology. So a dual home topology provides redundancy. As shown in the figure, 2 hub routers are dual homed and redundant attached to the 3 spokes across the one cloud. So you've got redundancy here between the spoke and the hubs. The advantage of a dual home topologies is that they offer enhanced network redundancy, load balancing, distributed computing and processing, and the ability to implement backup service provider connections. All right. So the disadvantage is that they are more expensive to implement than single home topologies. This is because they require additional networking hardware, such as routers and switches. All right. So dual home topologies are also more difficult to implement because they require additional and more complex configurations. Okay. Next is a fully meshed topology. Okay. A fully meshed topology uses multiple virtual circuits to connect all sites, as shown in the figure. So each of these sites are connected or directly connected to each other. This is the most fault-tolerant topology of the 5 shown or presented. For instance, if site B lost connectivity to site A, it could send data through either site C or site D. All right? So partially meshed topology is connected but not on all sites. For example, in the figure, sites A, B, and C are fully meshed to each other, while site D, all right, must connect to site A to reach B and C. So that is partially meshed topology. All right, let's talk about the WAN connections or the carrier connections. So another aspect of WAN design is how an organization connects to the internet. So an organization is usually signs a service level agreement or SLA with a service provider. So the SLA outlines the expected services relating to the reliability and availability of the connection. So the service provider may or may not be the actual carrier. A carrier owns and maintains the physical connection and equipment between the provider and the customer. So typically, an organization will choose either a single carrier or a dual carrier WAN connection. All right, so for a single carrier connection, this is when an organization connects to only one service provider. All right, as shown in the figure here. So an SLA is negotiated between the organization, all right, and the service provider. The disadvantage of this design is the carrier connection and the service provider are both single points of failure. So connectivity to the internet would be lost if the carrier between the provider, okay, and the customer or the corporate site here failed. Okay, so we have here a single point of failure. Now for the dual WAN connection or the dual carrier connection, a dual connection provides redundancy and increases network availability as shown in the figure here. So the organization negotiates separate SLAs with two different service providers, ISP1 and ISP2 here. So the organization should ensure that the two providers each use a different carrier. All right. So for example, we have here two competitors. For example, you've got PLDT and Globe. All right. So that's how you choose an ISP. It should be a competing vendors. So the organization should ensure that the two providers each use a different carrier, that's what I'm saying. So although more expensive to implement, the second connection can be used as redundancy or a backup link. All right? So it could also be used to improve the network performance and load balance internet traffic. All right. So for the purpose of demonstrations here and case study, okay, so let's have an example, okay, so which is the evolving network, okay. So we will be using the span engineering, okay. So span engineering is an environmental consulting firm has developed a special process for converting a household waste into electricity and is developing a small pilot project for a municipal government in its local area. Okay? So, for example, network requirements of a company can change dramatically as the company grows over time. And we will be using the span engineering, a fictitious company here, to show how networks evolve. All right? So, a network must meet a day-to-day operational needs of a business, and it must be able to adapt and grow as the company changes. Okay? So network designers and administrators meet these challenges by carefully choosing a network technologies, protocols, and service providers. So networks can be optimized by using a variety of network design techniques and architectures. So to illustrate differences between network size, that's what I'm saying earlier, so we will be using the span engineering as our subject here. Okay? So, span engineering started as a small network. Okay? So the company initially consisted of 15 employees working in a small office as shown here. So they used a single LAN that was connected to a wireless router for sharing data and peripherals. So they've got a router here. They share the information and data over the wireless connection. So they used a single LAN that was connected to a wireless router for sharing data and peripherals. The connection to the internet is through a common broadband service called DSL, right? So this company here is connected to a single ISP provider and they are shared over the infrastructure. Okay? So to support their IT requirements, they contracted services from the DSL provider. Okay? Next. So after some time, that small network is now a campus network. So within a few years, SPAN grew into a larger network or a larger organization and required several floors of the building. All right. So the company now required a campus area network or CAN. So a CAN interconnects several LANs within a limited geographical area. So multiple LANs are required to segment the various departments that are connected to multiple switches in a campus network environment. So the network includes a dedicated server, all right? So they have now dedicated servers for email, data transfer, file storage, web-based productivity tools and applications. So they even have the firewall, all right, which secures internet access to corporate users. So the business now requires an in-house IT staff to support and maintain the network. Okay, so span engineering has evolved from the small network now into a campus network. Okay, so a few years later, so the company expanded and added a branch. Okay, so and then they have now the remote and regional sites in other cities as shown here. All right, so they have now this regional office. They've got remote office one, branch office connected to the central office. Okay, so the company now required a metropolitan area network or MAN to interconnect sites within the city. So a MAN is a larger than the local area network but smaller than one. So to connect to the central office, branch office is nearby in nearby cities use private dedicated lines through their service local provider. So offices in other cities and countries require the services of a wide area network or may use internet services or services to connect distant locations. So however, the internet introduces security and privacy issues that the team or the IT team must address. All right. So Span now has different branches from the small network to campus network. Now we have the branch network. All right. So Span Engineering has now been in the business for 20 years and has grown to thousands of employees distributed offices worldwide as shown in the figure here. All right. So to reduce the network costs, Span encouraged teleworking and virtual teams using a web-based applications, including web conferencing, e-learning, online collaboration tools to increase productivity and reduce costs. So site-to-site and remote access virtual VPNs enables the company to use the internet to connect easily and secure with employees and facilitates, okay, so the requirement of the organization all over the area or around the world. Okay. Now, so let's discuss the WAN operations. Okay. So first, let's talk about the WAN standards. So now that you understand how critical WANs are to a large network, so this topic discusses how they work. So the concept of WAN have been around for many years. Okay. So consider that the telegraph system was the first large-scale WAN, followed by a radio, telephone system, television, and now you've got the data networks. Okay? So many of the technologies and standards developed for these WANs are used as the basis for the network wide area network or WANs. Okay, so modern WAN standards are defined and managed by the number of recognized authorities, including the following here. So you've got the EIA, TIA, or the TIA, EIA, you've got the ISO and the IEEE. Okay, so these three organizations are widely known for the standards. All right, next, where is the WAN or wide area network on our OSI model? So basically, when we're talking about the wide area network, so we are limited only on these two, or the first two layers here, the physical layer and then the data link layer. This is where your wide area network operates. All right. So layer 1 protocols describes the electrical, mechanical, operational components needed to transmit bits over the wide area network. So for example, service providers commonly use high bandwidth optical fiber to span long distances. So we call it long haul, all right, using the following layer 1 optical fiber protocol standards. So we have here the synchronous digital hierarchy, or the SDH, the synchronous optical networking, or the SONET, and we have this WDM, which is the dense wavelength division multiplexing. Okay, so the SDH and SONET essentially provide the same services, and their transmission capacity can be increased by using the DWDM technology. All right, now let's talk about this layer 2 protocols here. So layer 2 protocols define how data will be encapsulated into frames. Okay, so way back referring to your Cisco 1, 2, and 3. Okay, so layer 2 protocols encapsulates into frame. Okay, so the PDU on a layer 2 is what you call frame. Now, several layer 2 protocols have evolved over the years, including the following. So you'll have here the broadband, right? So that includes the DSL and the cable. You've got wireless, Ethernet 1, or the Metro Ethernet. You've got the MPLS, or the multi-protocol label switching. We have PPP, or the point-to-point protocol, which is least used nowadays, right? You also have the HDLC, or the high-level data link control, which is also least or less used. You've got the frame relay, so which became already a legacy. So it was part of the previous curriculum before, all right? And you've got the ATM, which is also now a legacy. So legacy are old technologies, and there are at least some organizations who are still using it. All right? Okay, so next are the terminologies in the wide area network. So there are specific terms used to describe a wide area network connections between the subscriber and the WAN service provider. Okay, so the WAN physical layer describes the physical connections between the network or the company network and the service provider network. So you'll have here the DTE. Okay, let's start with this first term here. DTE connects the subscriber's LAN to the WAN communication devices. Okay, so inside hosts send their traffic to the DTE device. The DTE connects to the local loop through the DCE. And the DTE device is usually a router, but cannot be a host or a server. That's DTE. So commonly it is a router. All right. So next is DCE. What is DCE? DCE is a device used to communicate with the provider. So this is also called as the data circuit terminating equipment. Okay, and the DCE primarily provides an interface to connect to the subscribers to a communication link in a WAN cloud. So the third one is CPE, or the customer premise equipment. So this is the DTE and DCE devices located on a large edge, or on the enterprise edge. Sorry. Okay. Now, CPE is basically, that's what I've said, the DTA and the DCE devices. So it could be a router, a modem, optical converter. Okay, so located on the enterprise edge. So the subscriber either owns the CPE or leases the CPE from the service provider. Okay? So the third term, okay, so that is being used in a WAN is a point-to-point or the point of presence or POP. So the point where the subscriber connects to the service provider network. Okay? Next is a demarcation point or DP. Okay? So this is the physical location in a building or complex that officially separates the CPE from the service provider equipment. Okay? So that is your demarcation point. All right? So the demarcation point is typically a cabling junction, okay, located on the customer premise that connects to the CPE wiring to the local loop. So it identifies the location where the network operation responsibility changes from the subscriber to the service provider. So when problem arises, so it is necessary to determine whether the user or the service provider is responsible for troubleshooting or repair. Okay, so that is the boundary. Okay, that is the boundary between the service provider and the organization. Okay, so the responsibility of the service provider ends here, and your responsibility, for instance, as network administrator of the organization, begins. All right. Okay, so you also have the local loop or the last mile. All right. So this is the actual copper or fiber cable that connects the CPE to the CO, central office of the service provider. Okay, and the central office is the local service provider facility or building that connects the CPE to the provider network. All right, so we have a lot of terms here. You also have the toll network. So toll network, this includes backhaul or long haul, all digital fiber optic communication lines, switches, routers, and other equipment inside the WAN provider network. Okay, so you also have the backhaul here. Okay, so which is not shown on the diagram. Backhaul networks connects multiple access nodes of the service provider network. So backhaul network can span over municipalities, countries, and regions. Okay, so backhaul networks also is connected to the ISP and to the backbone network. All right, so next is the backbone network. So backbone network is not also shown on our diagram here. So these are large high-capacity networks used to interconnect service provider networks and to create redundant network. So other service providers can connect to the backbone directly or through another service provider. Okay? So backbone network service providers are also called the Tier 1 or the T1 providers. All right. Next, let's talk about WAN devices. So what are the components we used in implementing wide area network? So these are many types of devices that are specific to wide area network environments. However, the end-to-end data path over the WAN is usually from source DTE to the DCE, then the WAN cloud, then to the DCE, to and finally to the destination DTE, as shown on our diagram here. Okay? So there are many types of devices that are specific to WAN environments, and these are listed here on this table. So this includes the voice band modem, okay, so also known as the dial-up modem, okay. So legacy device that converted or modulated the digital signals produced by the computer into an analog voice frequencies. So it is being used by telephone lines to transmit data. All right, so we call it analog modem. All right, so the next one is a DSL modem or a cable modem, so collectively known as broadband modems. So these are high-speed digital modems that connect to the DTE using an Ethernet. All right. Next, you've got the CSU DSU. Okay, so CSU DSU is a digital list lines requires a CSU and a DSU. So it connects a digital device to a digital line. So digital to digital. All right. So a CSU DSU can be a separate device like modem, or it can be an interface on a router. So the CSU provides termination for digital signal and ensures connection integrity through error correction and line monitoring. So the DSU converts the line frames into a frames that the LAN can interpret and vice versa. All right. Next is optical converter. So what is an optical converter? So also known as the optical fiber converter. Okay. So these devices cannot or connect fiber optic media to copper media and convert optical signals to electrical or electronic pulses and vice versa. So we call it adapter. All right. Next is a wireless router or an access point. Okay. So these are devices that are used to wisely connect or wirelessly connect to a device to a WAN provider. So routers can also be used, okay, or could also use cellular wireless connectivity. So that would depend on the need of the organization. All right. Next is WAN core devices. Okay. So the WAN backbone consists of a multiple high-level routers or high-speed routers and layer 3 switches. Okay. So a router or a multi-layered switch must be able to support multiple telecommunication interfaces of the highest speed used in a WAN core. So it also must be able to forward IP packets at full speed on all those interfaces. So the router or multi-layer switch or layer 3 switch must be supported or must support the routing protocols being used in the core. All right. Okay. Now let's talk about serial communication. So this is still part of the WAN operations. Okay. So I might ask you what is or which one is faster, a serial or a parallel communications? Okay. So maybe you'll give me an answer parallel. Why? Because in parallel, we have multiple lines, okay, so which are being used to transmit data from the source to destination. All right. Whereas for serial communication, you only have one line to transmit this 8 bits of data from the source to destination. So that would take, okay, if we are going to transmit this 8 bits here to the destination, after 8 milliseconds, transferring 8 bits in 1 millisecond, so we will be able to transfer 8. All right. Whereas in here, we were able to transfer only 8 bits, right? Whereas in here, it's a byte. All right. Now, so although parallel connections theoretically transfers data 8 times faster than the serial connection, it is prone to synchronization problem. All right. So as the cable length increases, the synchronization timing between multiple channels becomes more sensitive to distance. So for this reason, parallel communication is limited to a very short distances. All right. So example, copper media is limited to less than 8 meters or 26 feet. That's why mostly nowadays we are using serial communications. Okay. So two of the major factors that affects parallel communications are the attenuation. Okay. So attenuation meaning as the length of the segment increases, the resistance increases, and therefore, so some of the data will not be able to reach the destination. Okay, so even though this information or bits here left the source all at the same time, what actually happens while in transit is that some of the bits are left behind. So it also forms a skew. All right, that's a problem in parallel communications. Okay, so therefore, parallel communication is not a viable WAN communication method because of its length restrictions. All right. So it is, however, a viable solution in data centers where distances between the servers and the switches are relatively short. All right. So, for instance, the Cisco Nexus switches in data centers support parallel optics, okay, to transfer more data signals and achieve higher speeds, something like 40 Gbps or 100 Gbps. All right, so but mostly on long distance communications, we are using serial. All right, you've got the USB or the universal serial bus. All right, next. So you've got the WAN operations. So network communications can be implemented using either the circuit switch communication, okay, or the packet switch communication. So a circuit switch network establishes a dedicated circuit or channel between endpoints before the users can communicate. Okay. So for example, on this diagram here, if telephone A here would like to make a call to telephone B, all right, so it has to start establishing a link to be used prior to um, the conversation or the communications. All right. So specifically, circuit switching dynamically establishes a dedicated virtual circuit through the service provider network before voice or data communication can start. So before you can reach each other, you have to establish first the link, right? And that link, that um, communications or connections are fixed. All right. So for example, that's what I'm saying. When user A, okay, when the user makes a telephone call using a landline, for instance, so the number called is used by the provider to create a dedicated circuit from the caller to the called party, which is B. So during transmission, the circuit switch network, all communication uses the same path. So the entire fixed capacity allocated to the circuit is available for the duration of the connection. So regardless of whether there is an information to transmit or not. All right. So this can lead to inefficiencies in a circuit usage. So for this reason, circuit switching is generally not suitable for data communications. And these are usually used on telephone lines. All right. Okay. So next is a packet switched communication. What is a packet switch communication? So network communications is most commonly implemented using a packet switched communication. So in contrast to the circuit switching, packet switching segments traffic data into packets that are routed over the shared network. So packet switched networks do not require circuit to be established. Okay? And they allow many pairs of nodes to communicate over the same channel. So from the diagram here, okay, so for example, server 1 will be sending data to server 2. Okay, so packet traverses in any directions. Okay, so packet switching is much less expensive and more flexible than circuit switching, although susceptible to delays or latency and variability of delay, okay, so which is jitter, right? So modern technology allows satisfactory transport of voice and video communications on these networks, and it has proven via the use of the VoIP. All right. So common types of packet switched WAN technologies are the Ethernet WAN, okay, or the Metro Ethernet, the MPLS, as well as the legacy frame relay and legacy ATM. So these are under packet switching communication. All right. Okay. Next, you've got SDH, SONET, and DWDM. So we mentioned these terms earlier, okay, early in the discussions. So both standards are essentially the same, and therefore they can often listed as SONET SDH. So we're talking about the first two here. Okay? So service provider networks use fiber optic infrastructures to transport user data between destinations. So fiber optic cable is far superior over the copper cable for long distance communications. Okay? So due to having a much lower attenuation and interferences. So I have mentioned earlier about attenuation. All right? Okay. So this is the DWDM. Okay? It has the following features. It supports SONET and SDH standards. It can multiplex more than 80 different channels, example, wavelengths, into a single fiber. Okay? So each channel is capable of carrying 10 Gbps multiplexed signal. It assigns incoming optical signals to specific wavelengths of light, example, frequencies. Okay? So it assigns incoming optical signals to specific wavelengths, what we call frequencies. And in DWDM, okay, so these are commonly used in long-haul systems and modern submarine communication cables, just like connecting the Philippines to the rest of the world. All right, so we rely on the submarine cables, and most of it are using DWDM. All right, okay. So on the next slides, we will be talking about the different WAN connectivity. Okay, so let's start with the traditional WAN connectivity options. So to understand the WANs of today, it helps to know where they started. So let's talk about a little bit of history here. Okay, so when the LANs appeared in the 1980s, organizations began to see the need to interconnect with other locations. So to do so, they needed their networks to connect to the local loop of a service provider. So this was accomplished by using a dedicated lines or by using a switched services from the service provider. Okay? So the figure here, okay, summarizes the traditional WAN connectivity options. And the traditional WAN connectivity options are divided into two. Okay, so you've got the dedicated and the switched network. So under dedicated, we're talking about list lines. And we're talking about the T1 connections or the E1 connections, right? So T3 and E3 connections. Now for the switched connectivity, it has been divided into two. You've got the circuit switching and the packet switching. Under the circuit switching, these are usually used by telecommunications, all right? That's why you'll have here the PSTN or the public switch telephone network. And the digital counterpart, ISDN, or the integrated service digital network. All right, so 56 kbps PSTN versus 64 kbps ISDN. Okay, now on the packet switch, we already have these obsolete technologies, all right, or almost a retiring technology, which includes frame relay and the ATM. Okay, so there are several one access connection options that are or that the enterprise edge can use to connect over the local loop to the provider. So these one access options differ in technology, bandwidth, and cost. So each has a distinct advantages and disadvantages. So familiarity with these technologies is an important part of the network design. All right, and also you have to identify first whether these technologies are available on your work area before you propose one. Okay? Next. So you'll have here the common WAN terminologies. Okay? So when permanent dedicated connections were required, so a point-to-point link using a copper media was used to provide a pre-established WAN connections or communications between the customer premise to the provider network. So point-to-point lines could be leased from the service provider, and we called it list lines. All right. So the term refers to the fact that the organization pays a monthly list fee to a service provider to use the line. Okay, list lines. So list lines have existed since the early 1950s. And for this reason, these are referred to by different names such as list circuits, serial link, serial line, point-to-point link, okay, even the T1, E1, T3, E3 lines. So list lines are available in different fixed capacities and are generally priced based on the bandwidth required and the distance between the two connected points. All right, so it's a little bit expensive. Okay, so there are two systems that used to define the digital capacity of a copper media serial link. Okay, so these are this T carrier here, and you've got the E carrier. Okay, so what's the difference? The T carrier are used in North America. Okay, so T carrier provides T1 links supporting up to 1.544 Mbps and T3 links supporting up to 43.7 Mbps. All right. Now the E carrier, E stands for the European, no? So it is used in Europe. The E carrier provides E1 link supporting bandwidth from 2.048 Mbps and the E3 link that supports up to 34.368 Mbps. Okay? So the copper cable physical infrastructure has largely seen replaced by optical fiber network. So transmission rates in optical fiber network are given in terms of OC. All right. So aside from these standards, we have the OC or the optical carrier transmission rates, which defines digital transmitting capacity of a fiber optic network. All right. So next, common WAN terminology. So this table summarizes the advantages and disadvantages of list lines. Okay. So advantages, list lines, point-to-point, simplicity. All right. Point-to-point communication links usually offer high quality service, quality, we're talking about quality, and availability. So disadvantage, of course, are costs and limited flexibility. Okay? So, but then we look at it more on the advantage side. Okay? Next, circuit switched options. So we have mentioned these circuit switched options earlier. You've got the PSTN or the dial-up or the analog communication having 56 kbps, all right? So also known as the dial-up internet. And you also have the ISDN or the Integrated Services Digital Network, a digital counterpart of PSTN which runs 64 kbps, no? So because of the combining capacity, so ISDN provides for data rates from 45 kbps up to 2.048 Mbps. All right. So if this one is 56, this one is 64, or ranges from 45 to 2.048. Okay. So dial-up access is considered to be a legacy WAN technology. Okay. So however, it may still be viable solution when no other WAN technology is available. As long as you have the telephone lines, you could access the internet. So thanks to dial-up access. All right. So ISDN, okay, so ISDN has declined greatly in popularity due to high-speed DSL and other broadband services. So ISDN is considered a legacy technology, with most major providers discontinuing this service. All right. Next, how about the packet switched options? Okay. So packet switching segments. So these are the two legacy protocols which are used in packet switching. You've got the frame relay and the ATM. Okay. So frame relay is a simple layer 2 non-broadcast multiple access or NBMA WAN technology that is used to interconnect enterprise LAN. Okay. So I have experience configuring frame relay, and then I find it simple. All right. See, this is the most economical solution before. Okay. So the frame relay creates PVCs. Okay, which are uniquely identified by the data link connection identifier or the DLCI or DELCs. So they read as DELCs. Okay. So ATM is also a legacy. Okay, so asynchronous transfer mode technology is capable of transferring voice, video, and data through a private and public networks. Okay, so ATM is built on a cell-based architecture rather than frame-based, which are being used by frame relay. Again, these two options were already obsolete. Okay, now let's talk about the modern WAN connectivity. So what are the options here? Okay, so modern ones have more connectivity options than traditional ones. So enterprises now require faster and more flexible WAN connectivity options. Traditional ones connectivity options have rapidly declined in use because they are either no longer available, too expensive, or have limited bandwidth. All right. So what are the options that we have for the modern day WAN connectivity? So we have what you call a dedicated broadband, a packet switched, and an internet-based broadband. Okay. So under the dedicated broadband, okay, so we have this broadband and the dark fiber. Okay. So fiber can be installed independently by an organization to connect remote locations directly together. Okay, so we call it fiber, but a much faster than the ordinary fiber. We call it dark fiber, which can be leased or purchased from the supplier. Okay. Next, you've got packet switched, right? So this includes Ethernet 1 and MPLS. So the Metro Ethernet replacing many traditional WAN options, and you also have the MPLS, which enables sites to connect to provider regardless of its access technologies. All right. And the third one is the internet-based connectivity options. So this includes the broadband VPN. Okay. So we have here the wired XDSL. Okay, you've got the ADSL, SDSL. Okay, so cable, optical fiber, and then for wireless, we have municipal Wi-Fi, cellular, satellite internet, and WiMAX. Okay, so there are several WAN access connection options that the enterprise edge can use to connect over the local loop to the provider. So these WAN access connections or options differ in technology, bandwidth, and cost. So each has a distinct advantages and disadvantages. So familiarity with these technologies is important part of the network design. Okay? So also, as what I'm saying, there should be, or you should know as network administrator, if these services are provided on your work area. Okay? Next. So Ethernet was originally developed as a LAN access technology and was not suitable for WAN access technology due primarily to the limited distance provided by copper media. Okay? However, newer Ethernet standards using fiber optic cables have made Ethernet a reasonable WAN access option. All right. So for instance, you have the IEEE 1000 base LX standards which supports fiber optic cable lengths of 5 kilometers. Okay. So it go beyond the initial length of fiber optic, which is 2 kilometers. Okay. So while the IEEE 1000 base ZX supports the lengths of up to 70 kilometers. All right. So in here, service provider now offers Ethernet 1 service using fiber optic cabling. In the Philippines, most of the internet nowadays, they prefer fiber. All right. So it uses fiber optic cable to connect to the ISP or to the provider. Okay. So the Ethernet 1 service can go by many names, including the Metro E, you've got the EOMPLS, you've got the Virtual Private LAN service or the BPLS. All right. So we have a lot of technologies available. So there are several benefits to an Ethernet 1. So reduced expenses and administration, easy integration with existing network, and enhanced business productivity. Okay. So Ethernet WANs have gained popularity and are more commonly being used to replace the traditional serial point-to-point frame relay and ATM WAN links, which we mentioned earlier were already obsolete. All right. Okay, so let's talk about MPLS, okay, or the multi-protocol label switching. Okay, so this is a high-performance service provider WAN routing technology to interconnect clients without regard to the access method or payload. Okay, so an MPLS router can be a customer edge CE router or a provider edge PE router. Okay, so in here, you've got PE here and you've got CE routers here. Okay, or an internal provider P router. Okay, notice that MPLS supports a variety of client access connections. So MPLS routers are label switch routers or the LSRs. Okay, this means that they can attach labels to packets that are then used by other MPLS routers to forward traffic. So when the traffic is leaving the CE, the MPLS PE router adds a short fixed length label in between the frame header and the packet header. So the MLSP router, okay, this one, use the label to determine the next hop of the packet. So the label is removed by the egress PA router, okay, when the packet leaves the MPLS network. So MPLS provides a service for the quality of service support, all right, traffic engineering, redundancy, and VPNs. Okay, now for the internet-based connectivity options, so we have two. You've got the wired options and the wireless options. Okay, so modern WAN connectivity options do not end with Ethernet WAN and MPLS. So today, there are most hosts of the internet, wired and wireless options from which to choose from. Okay, so that includes the internet-based broadband connectivity as an alternative to using a dedicated WAN options. Okay, so the figure lists the internet-based connectivity options here. Okay, so that we mentioned earlier. Okay, so we're enjoying the cellular. Okay, so some of us are connected to WiMAX. Okay, most of us are connected to optical fiber and so on. Okay, next, DSL or the digital subscribers line. Okay, DSL is a common internet connectivity. This is a high-speed, always-on connectivity or connection technology that uses the existing twisted pair telephone lines to provide IP services to users. All right. So from the diagram here, okay, so the area labeled POTS is the plain old telephone systems. Okay. So it identifies the frequency range used by the voice grade telephone service. The area labeled ADSL, all right, this one here, represents the frequency space used by the upstream upload and downstream download DSL signals. So this area that encompasses both the POTS and the ADSL area represents the entire frequency range supported by the copper wire pair. Okay, so there are several XDSL varieties. Okay, so using different upload and download transmission rates. However, all forms of DSL are categorized either the ADSL or the SDSL. Okay, simple as that. Okay, ADSL, you've got a greater download compared to upload. So that's the most common implementation on the household. Okay, so if you are subscribed to the internet, of course you want your download to be higher. That's ADSL. Okay, so ADSL provides higher downstream compared to that of upstream, while SDSL provides the same capacity in both directions. All right, and these are usually used by businesses. All right, so next is you also have the DSL connections. Okay, so the DSL modem converts the Ethernet signal from the teleworker device to a DSL signal, so which is transmitted to DSL access multiplexer. DSLAM at the provider location. Okay? So the DSLAM is the device located at the central office of the provider and concentrates connections from the multiple DSL subscribers. A DSLAM is often built into an aggregation router. So the advantage that the DSL has over the cable technology is that DSL is not shared medium. Each user has a separate direct connection to the DSLAM. So adding users does not implement or impede performance, okay? Unless the DSLAM internet connection to the ISP or to the internet becomes saturated, okay? Next, so it's a long discussion here. The next one is a PPP, okay? DSL and a PPP. So PPP is a point-to-point protocol. This is a layer 2 protocol that was commonly used by telephone service providers to establish router-to-router and host-to-network connections over a dial-up and ISDN access networks. Okay, so ISP still use PPP as the layer 2 protocol for broadband DSL connections because the following factors are considered. Okay, so you'll have this. So PPP can be used to authenticate the subscriber. PPP can be or can assign a public IPv4 address to the subscriber, and PPP provides link quality management features. All right. So next, a DSL modem has a DSL interface to connect to the DSL network, and an interface or Ethernet interface to connect to the client device. However, the Ethernet links do not natively support PPP. Okay, so there are two ways that PPP over the Ethernet or the PPPoE can be deployed. It's either host with PPPoE client or router PPPoE client. Okay, so what's the difference between these two? Okay, so as shown in this figure, the host runs PPPoE client to obtain a public IP address from the PPPoE service located at the provider site. All right. So the PPPoE software or client software communicates with a DSL modem using the PPPoE, and the modem communicates with the ISP using PPP. Okay. So in this topology, only one client can use the connections. Also notice that there is no router to protect the inside network. Okay, on the host with PPPoE client. Now, on the other hand, another solution is to configure a router to be a PPPoE client, as shown in the figure here. So you got router here. So the router is the PPPoE client and obtains its configuration from the provider. Okay. So the clients communicate with the router using only an Ethernet and are unaware of the DSL connection. So in this topology, multiple clients can share the DSL connections. So again, this would vary depending on the need of the organization. Okay? So another internet-based connectivity to look or to consider is the cable technology. So we have this cable internet, right? Okay? So the cable technology is a high-speed, always-on connectivity technology that provides or that uses coaxial cable from the cable company to provide IP services to users, just like the Sky Internet. Okay, so like DSL, cable technology is a popular choice for home users and for enterprise IT department to support remote workers. So it uses what you call DOCSIS. Okay, DOCSIS is a data over cable service interface specifications. Okay, that is an international standard for adding high bandwidth data to an existing cable systems. Okay, so the cable operators deploy hybrid fiber coaxial or the HFCs networks to enable high-speed transmission of data to cable modems. So the cable system uses a coaxial cable to carry radio frequency signals to the end users. So there are some of you here who are connected to internet via the cable internet. Okay, so a popular brand here is the Sky Internet. Okay. Next is the optical fiber. So most of us are connected using a fiber, okay? Fiber to the home, or fiber to the building, or fiber to the node or neighborhood, okay? So they uses fiber optic to connect you to the internet, okay? So fiber to the home is common. So fiber reaches the boundary of the residence. So fiber to the building, or the FTTB, fiber reaches the boundary to the building with the final connection to the individual living space being made via alternate means. All right? And the fiber to the node or to the neighborhood. Okay, so this vary in terms of sizes. All right? Okay, so next is for the wireless option. So we have the municipal Wi-Fi. Okay, so municipal Wi-Fi wireless networks are available in many cities, providing high-speed internet access for free, okay, or for substantially less than the price of the broadband services. Okay, usually these are government-sponsored Wi-Fi. Okay, you also have the cellular technology. Okay, so which we are enjoying the LTE. All right, so you've got the 3G, 4G, and then the 5G, and then of course the LTE. Okay. So next one is the satellite internet, accessing the internet via the use of the satellite. So that's an expensive option. And the last one is WiMAX. It's a worldwide interoperability for microwave access, or WiMAX, described in the IEEE standard 802.16. Okay? So in the Philippines, the ISP, or the popular ISP, offers this WiMAX service. All right? Okay, so next is a VPN technology. So VPNs can be used to address the security concerns incurred with a remote office worker uses broadband services to access the corporate WAN over the internet. So this is the cost-effective solution nowadays to connect your site to the internet. Okay? So these are the several benefits of using VPN. So cost saving, security, scalability, and the most important thing is the compatibility with the broadband technology. So we have several types or implementation of VPN that we are going to cover on the rest of the discussions. Okay, and this includes site-to-site VPN and remote access. Okay. Next, for the ISP connectivity options, so that would depend on you. Okay, so you have the single homed. Okay, so when you say single homed, single connection to the ISP using one link, provides no redundancy, and this is the least expensive solution. So when this internet or when this link goes down, then you are disconnected. That's single home. All right. So dual home connects to the same ISP, but you have the redundancy. Okay, that's dual home. Now, what's not good about this one is you are connected to the same ISP. What if the ISP goes down? Then you have no connection. All right. So you might want to consider the multi-homed. Okay. So wherein your client is connected to two ISPs. Okay, having their own link. Okay. So this can be expensive, but you have the redundancy here. If ISP1 goes down, you still have the ISP2. Okay. Or you might want to consider the fourth one, which is the dual multi-homed. Okay. So wherein you are connected to two different ISPs and not just a single cable, but it provides redundancy also. So this is the best solution. Okay, but it's the most expensive among these four. All right. Okay, so presenting all these technologies available. Okay, so you as as network administrator. Okay, so you can choose which one to implement on your organization. So would it be using cable internet, DSL, fiber to the home, okay, mobile or cellular, municipal Wi-Fi or satellite. All right? So it's the option is now yours. Okay? So you choose one. Which one to implement on your organization. So there are some advantages and disadvantages on it. Okay? So That's the end of this discussion. Okay. So thank you so much for listening. Have a great day.